Good morning, everyone. In today's session, we are going to discuss binomial distribution. Binomial distribution is a theoretical distribution, and suppose we have a random experiment having two outcomes. Let's say the success and the failure. Success is having probability P, and the failure is having probability Q, giving P plus Q, probability of success plus probability of failure is equal to 1. Suppose that the experiment is conducted n times independently, let's say x1, x2, x3 up to xn, and let x is equal to x1 plus x2 plus etc. up to xn, where each xi is taking 0 or 1 value depending on success or failure. Now, let's say we are defining probability of x equal to x, which is equal to, means the probability that there are exactly x success in n trials, which is equal to ncx given by ncx p raised to x q raised to n minus x. This is the probability that there are exactly n success. This is representing that there are ncx ways combination, ncx combination for x successes and n minus x ways for getting the probability q, that is having failure probability q. We know that summation probability, which is equal to summation ncx p raised to x q raised to n minus x, where x is varying from 0 to n, is equal to, this is p plus q the whole raised to n, and we know that p plus q is equal to 1, so 1 raised to n is equal to 1. This defines a probability density function, and it is called binomial distribution. In this distribution, we are having only two parameters, n, the number of trials, and p. Anyway, we know that q is equal to 1 minus p. So there are only two independent parameters, n and p. Now, this binomial distribution is used only when n is less than or equal to 100, because ncx becomes very large as n increases. And the probabilities are the terms of p plus q the whole raised to n, p plus q the whole raised to n. That's why it is called binomial distribution. Now, moving to find the mean of the distribution. Mean is denoted by expectation of x. This is equal to summation x probability of x, which is equal to summation x times probability is given by taking x successes is given by ncx p raised to x q raised to n minus x, which is equal to summation x is varying from 0 to n x times n factorial divided by n minus x factorial into x factorial p raised to x into q raised to n minus x. So this is equal to summation x equal to 0 to n factorial divided by n minus x factorial into x minus 1 factorial, because x into x factorial can be represented as x into x minus 1 factorial, and x will cancel with the numerator 1. Now this is equal p raised to x q raised to n minus x. Now this is equal to summation x equal to 0 to n. I'm writing n factorial as n into n minus 1 factorial divided by n minus x factorial into x minus 1 factorial into p raised to x minus 1 q raised to n minus x. So this is equal to, I'm taking np outside, summation. Since x, I'm deleting 1, x will be varying from 1 to n. Here also 1 to n, np x equal to 1 to n, n minus 1 factorial divided by n minus x factorial into x minus 1 factorial. P raised to x minus 1, q raised to n minus x. Now I can represent this as np summation. If I call n minus 1 equal to j, x minus 1 equal to j, j is varying from 0 to n minus. So j factorial divided by, sorry, n minus 1 factorial divided by n minus j minus 1 factorial, n minus x factorial, sorry, n minus j plus 1 factorial into x minus 1 means j factorial into p raised to j q raised to n minus j plus 1. So this is equal to np times p plus q the whole raised to n minus 1. P plus q we already know, this is equal to 1. So mean or expectation of x is given by n times p. Similarly, we can prove that variance is equal to, variance of the binomial distribution is equal to n times pq, where p is probability of success and q is probability of failure.